title we've got on this, there's a reason it's called a master switch. That title was chosen because to me, my title was electrical systems. But they felt that that wasn't like cool. So we decided to go with, there's a reason it's called a master switch, so it's a pretty good system that way. My name is Tim Gaunt. I am the Director of Product Support for Hartzell Engine Technologies. We've got a variety of different companies. In fact, I forgot my little pull-up thing, but we got a variety of different companies. I want to thank AOPA. This is the first time I've ever done it for them, which is kind of cool. I kind of like this. Nice crowd. Looks like you all are interested, or you're just dead because it's the end of the day. You're fortunate because this is only a 2-hour presentation, and that's why they put me at the end. So we are good to go. So, all right, yeah, I have to put this on there. I received a call from the FAA a while back, a year ago, and they told me that they found my name in a logbook. And I thought to myself, this is not good news. I haven't physically signed an airplane off in like 30 years. And I thought, if you found my name in a logbook, this is a big deal, something's happened. And the guy said, no. He says, you're not in any problem. He said, actually, what we found was that a gentleman had installed one of our generator alternator conversion kits, and he used you as the reference for the installation. He said you were the approved data. Well, it don't work that way. So it was kind of interesting because they had to kind of like retrain him on what is acceptable data, what is approved data, et cetera. So I throw this in here because you got to use your manuals like you're supposed to. I don't care what work you do on the airplane. How many people in here are certified? And experimental? Okay, so we're splitting up. This can go either way for what we're talking about today. It can go either way because we've got regulation for certification, we've got regulation for experimental, so, I mean, there's just different things you all have to do. But bottom line is, if a manufacturer or whatever has a product, and that product is, and does have a manual, even if you're experimental, you're not supposed to just take that apart and just do whatever you want to do. It still falls under the guidelines of who owns the product. Now, if you choose to do that, obviously you're on your own. If you choose to use the manual, then you have our backup and support with it. So it's sometimes worth, kind of find out what data is out there that you could actually use to do whatever it is you're trying to do. Communication, this is the biggest thing I find that people have problems with. We do tech support all day long. There's one other gentleman and myself. He and I are on the phone or email all day long. And all we're doing is talking to people in the field and about problems they might be having, problems hopefully we can prevent them from having, and just generally getting information as much as we can to help them solve a problem. Do we solve everything? No. I've had several people up at the booth today, and I hope the information I told them was correct based on what they told me. So is good communication back to the person you're trying to work with to decide if it's going to get done, right the first time, as we like to say. Communication, keep it simple, obviously. Fix the problem, don't go after symptoms, don't run up the symptoms all the time. And this always kills me. Hydraulic versus electrical. I'll have a mechanic call me up and he'll say, I've got a problem with this electrical system. And it doesn't matter how hard it is or anything else. And he's working on let's say a 210. And he's got a 210 that he can tell me top to bottom how that hydraulic system works and every little nuance in it, but he gets to electrical, throws his hands up and says, I have no idea. What's the difference? They're both some type of flow. You got electron flow in an electrical system, you got hydraulic flow in the other. They both use accumulators, they both use wiring or tubing. There's a lot of similarities. So there's this stigma that electrical, I don't want to mess with that. That probably came to your kid, stuck your finger in a light socket, blew yourself up, and you said, I'm never touching that again. We're not doing that. Or else your mother did it for you to make sure you wouldn't do that. Hartzell Engine Technologies, we actually started with Kelly Aerospace. We bought their assets back in 2010, and we've added on a bunch of companies with Lamar and Jasco and Plain Power, et cetera, et cetera. A bunch of different ones. That's the companies, that's what brand names we use. We converted everything to brand names because it was too confusing. So we made it like even more confusing. Because what we did is now we have a Skytech Starter, and that Skytech Starter is any starter we build. Well, we all know there's Prestolite, Lamar, Skytech, B&C, there's all kinds of starters. So I don't know if that was more of a marketing thing than anything else. Out of Montgomery, Alabama, OE support. We do have some manuals that are published, some are not. They're actually on by subscription. But if you all have something you're trying to do and it's in the manual, I'm going to pull that section out and send it to you. You know, it's not a big deal. Just let me know. All right. So we energize a master switch. Turn the master switch on. What are we doing? Think about it. When we turn that master switch on, we are basically closing a battery contactor, master switch, master contactor, and we are bringing the battery online to the bus, right? So we got that thing on the bus now. We're also allowing so we allow battery voltage to the bus and battery voltage to the starter contactor, the back side of it. So we are now primed that we can go from there and we can turn on, do we turn on avionics then? I wouldn't. Do you turn on the alternator then? I wouldn't. I'd wait till I started the engine, right? You want to start the engine first, get everything stabilized, then bring the alternator online, and of course avionics is its own thing, so that's got to come on by itself, or you bring it on after that fact. You want the electrical system to stabilize, all right? A lot of people, we get this question all the time, should I have the alternator on when I start the engine? Why would you do that? Why would you do that to the alternator and to the regulator? Think about it. You're cranking the engine and the volts and the amperage go boom, 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 boom. That's what the regulator is seeing. And it's hard for that regulator then to compensate to what the alternator should be supplying. So just leave it off. It's starting on the battery anyway. Let the battery start it, bring the alternator on. You should see your amperage go up just a little bit, right? Because you discharged it from the battery. You're going to charge that back up using the alternator. So we got Ohm's law. Go to Ohm's law. Gosh, it's like 100 years there's been Ohm's law. And basically it's voltage, amperage, resistance, and then you have a power formula, which is power, intensity of flow, which is amperage, and the voltage, okay? So when we're doing them, volts, most of you are probably 12-volt systems, maybe a few 24s in here somewhere, all right? But think of voltage as it's called electromotive force. That's why it's represented by E. So that electromotive force is the amount of push. How much push do you have in the system? So if I've got an airplane and I've got the battery in the back of the airplane, and I've got a 12-volt system, and I've got to bring that battery power forward onto the bus and to the starter and the starter contactor, I have 12 volts of push from the back of the airplane all the way forward. So what we did is in about 1978, most of the certified airplanes went 28 volts. I got to correct that. There are only two electrical systems. There's 12 volt and 24. There's no 14, 15, 28, none of that. That's just a marketing thing. It has nothing to do with a true system. So we got 24 volt system, we got double the push. All right? By doubling the push, our amperage is going to be cut in half. By cutting the amperage in half, wiring size decreases dramatically. Right? So that's a good thing. And that's what we want, especially we want to lighten everything up. The airplanes got bigger, it's just a way to make the systems work actually a little better than they would have under the 12-volt system. Nothing wrong with the 12-volt, but they kind of reach their limit as the airplanes get bigger. The power formula is the amount of work. So that tells you how much work this can do, how much flow you got in amperage and the voltage itself. And you combine those together, that tells you how much power you have available. Okay? As an example, if you want to calculate this out, using the triangle, it's basically just as it looks. Top, left, and right. So for voltage, it's I, the amperage, which is the intensity of flow, times the resistance. That'll give you your voltage. Or you can divide it. V divided by I, V divided by R will give you the amperage. You can calculate all this stuff out. Power formula is the same thing. If you want to know what the power is, it's just the voltage times the amperage. So if you've got a 12-volt system and you've got 50 amps available, you have a potential power of 12 times 50. And I should have written that down. Whatever that works out to be. That's how many amperage, or that's how much power you have available. And where it comes into play is it's something like this. Take an older airplane, it's got landing lights, right? Got a 250-watt landing light out there. That 250-watt landing light in a regular 12-volt circuit, if we take this, 250 watts, and a 12-volt circuit's going to be about 21 amps. Okay? That's for just the landing light. Now, what if I take that landing light and I change it to an LED lamp? The LED lamp supplies the same visual, the same lighting as a 250-watt lamp, but it only draws 4.2 amps. So if the power required is only 50 watts, 4.2 amps. You've literally cut, 16 amps out of the system by changing one landing light. And what does that mean? If you're looking at some of the airplanes, especially the older airplanes, with the older airplanes, and you have a lot of radios and things like that, and you got old stuff, there's a formula of what they call continuous load and intermittent load. Continuous load is anything that's on, that you turn on and stays on for, let's say, 5 minutes. 3 minutes, 5 minutes, whatever you want to call it, doesn't make any difference. So a continuous load item, if we use 5 minutes, you get in the airplane, you start it up, you flip on your nav lights. Odds are they're going to be on for 5 minutes plus. You turn on the landing light. Maybe you have to where you fly. Maybe it's on all the time because whatever the requirement is. Maybe you leave that on. How about flaps? Flaps would be continuous or intermittent. Going to be on for 5 minutes? Probably not, right? How about landing gear? Would landing gear ever be considered a continuous load item? You better hope not, right? I mean, if you got the landing gear coming down and it takes over 5 minutes for it to come down, I think you got a bigger problem to worry about than the electrical. You got something else going on. So it's going to be an intermittent load. Intermittent loads we don't care about. Intermittent loads are covered by the battery. So you're looking at your continuous load items. I had a gentleman one time call me up. He said, he had a 172 or 172 RG or something. And he said, I have 55 amps of continuous load. Really? How did you figure that? I mean, how is that possible? You've got a 60 amp alternator, and what he was saying is the alternator couldn't cover it. How did you figure that out? Well, I took those circuit breakers on the bottom, I just added them all up. There we go. There we go. That's how you do it. Well, let's cut some of that out because technically, per the FAA, the continuous load on the electrical system can't be more than 80% of the capacity of the alternator output. So if I've got a 60 amp alternator, some old Ford style alternator, if I got a 60 amp alternator and I can have 80% continuous load, then what, 8, 8, 16, what, 50, what's that work out to be? 40, 48. So that works out to be 48 amps continuous load. How many airplanes out there right now, small airplanes, have 48 amps of continuous load? None. Now, maybe you put an air conditioner in? Yeah, now you might. Maybe you got an air conditioner that takes 30, 35 amps, 40 amps, something like that. Yeah, you might have something then. But basic avionics, lights, all that kind of stuff, there's no way you're going to get near that continuous load. So you should be fine. You shouldn't have any problem with that. It's a problem for me because when people call up and they don't have that, they don't understand that, we have to go back through that because we got to figure out what the load is before we can ever figure out what they need and why their system isn't performing properly. So that's kind of where all that comes into play. So let's see here. So there's all your continuous intermittent load items. All right, let's talk about starters. All kinds of starters. What kind do you like? Lightweight, heavyweight, old style Bendix, new style, solenoid operated, I don't know. There's so many starters out there. That's right, we make them. We have a whole bunch of starters out there. It's insanity. I don't know why we need all these different starters for one engine. I mean, for a Lycoming engine, over there we have 4 starters for a Lycoming engine, all of which will work on the engine. All are certified for the same engine. What in God's name do we need all those for? They go from heavier to lighter, all right? Lightweight starters. Why do people want a lightweight starter? Weight. You want to save weight, right? Why do we need to save weight? All right, I'm going to tell you a story. Tell you real quick here. This got me in trouble at Oshkosh 10 years ago, but I still kept my job. Guy had a 421, came up the booth, said, I want to buy lightweight starters. And I said, why? You're a 421, for God's sake. Why do you need a lightweight starter? You're not shifting CG. You basically just want it because he basically told me that's what everybody has. All right. If you want to save the weight, we're talking about a 421. So let's just say we take off the heavyweight starters at 15 pounds and we put on the lightweight starters at 9 pounds. We even go more than that. Let's say it's 8 pounds a starter. What's fuel weigh, 6 pounds? Let's say it's 6 pounds a starter that we save. So now you can, technically, you can put in an additional 2 gallons. That 2 gallons of fuel in a 421, it's not going to get you to the end of the runway. You already died. So if you've cut it that close where 2 gallons makes the difference, the rest of it's history. Doesn't matter. So what I told this gentleman, if you're that concerned about the weight, maybe we should just skip a few pieces of pie, and the weight will be down, and everybody will be happy, including the airplane. So my job is not to sell stuff. My job is to tell people what I think, my opinion, like we were just saying, everybody's got one opinion. My opinion, what is the best thing you can buy for the mission that you're trying to accomplish. Okay? All right, his history, who needs a starter? You don't need anything, just hand crank it, right? Just hand prop it, no big deal, just get out there and do it. That actually is cheating because if you notice on the wingtip, I'm not mistaken, there's a light on that wingtip. So this dude's got an electrical system and he's still out there hand propping it. That to me is a little silly. That's what the starter's for. Kettering, back in the old days, the story goes, there was GM for Cadillac. I can't remember his name, Leland. He was a GM for Cadillac. His wife went shopping or something in Detroit, went across the bridge, the car stopped or whatever, and his hand crank, and she couldn't crank it. So he sent one of his best buddies out to crank the car for her, crank the engine for her. He cranked it, gave it a crank, car started, but it kicked back and it broke his jaw. He died. It's 1919 or something like that, way back when. Obviously, you know, they didn't have the medical they had then. This upset the Leland guy real bad, so he said, I want an electric starting device for my motors. All right, so he went to Kettering. Kettering put a group of people together. They created the first electrical motor starting device. That was in 1915, and that company became Delco. And Delco's been around for like ever. Pretty much out of the aviation thing now as far as anything new or whatever. They got out of GA a long time ago, but they built tons of stuff. And it was all high quality, heavy, will last forever, you know, type of product. So that's where that came from. That's where the starters came from. Starter motor. A starter motor is nothing but a bunch of wires, right? You got wires coming in on one side, you got wires coming in the rotor side, on the armature side, and you basically just run current through them. If we run current through a wire, we create an electromagnet. If I take 2 magnets and I try to put the north ends together, I will never be able to do it. Right? North and south will stick together. North and south will not. So all I got to do is create an opposing force, and once I have an opposing force between the motor, the armature, and the outside field frame assembly with current running through them, it's going to oppose it, and the starter turns. So you have a turning starter. You need a more powerful starter, put more wire in it. You need a more powerful starter, run more current through it, and you'll have a more powerful starter. Okay? All right. Basically, you're going to have some type of, you got to engage it one way or another. There's a mechanical device, which is the old Bendix drives. A lot of you probably have dealt with the old Bendix drives. Sometimes they'd hang up and stick and things like that. And of course, now the current ones all go to a solenoid engagement. So whether it be on the outside of the starter or inside the starter, you energize the solenoid and motor. The solenoid closes, extends the starter into the ring gear if it's light combing, and then the motor starts to turn. Some of them are the old, like Continental, there are a lot of direct drive starters, you know, things like that, but you got to get them engaged one way or another. A lot of people don't like the Bendix drive. I don't know, I never had any problem with them, so, you know, it's kind of there again, it's what people want to buy. So we'll sell it. Motor itself, let's see here. Bendix assembly electric, we did that. Inrush current. Whenever you're doing the current on a starter, it's called inrush and constant current. So the inrush current is when you first hit the starter, wham, how much current does it take to get the motor to even turn in the first place? Once it starts turning, then you have a continuous current flow. We basically, for all of our starters, we basically use 190 amps for the inrush and then 90 amps for the continuous. So if you're doing a wiring on your airplane, you're building a new airplane, and you're going to wire it, then you take that 190 amps, that's an intermittent load, right? Starter better not be turning for 5 minutes. And an intermittent load, you're going to go to like AC 4313. You're going to say it's running 5 feet. I got an intermittent load of this, and that's the wire size you're going to actually use. Simple route, been that way forever. Been that way forever. All right. Crank slowly, weak batteries. Remember, resistance is voltage drop. Older airplanes have tons of resistance. Every connection is a possible resistance path. I've had several people over there today. We've been talking about starters that you hit the button or T or whatever, and it comes up and goes in, it stops, and that's it. You hit the again, and it finally goes through compression, and then it'll go. That can just as easily be a voltage drop in the system from the battery to the starter contactor to the starter itself and any connection in between. A lot of times, all you have to do is take all your connections, bust them all loose, wiggle the connection, tighten them back down, and you're good to go. Fix the whole thing without having to buy new parts. You buy a new starter, you take that cable off, you disassemble, you pull the starter off the engine, you put it back on, you grind the nuts down, you put the cable on, and you've done the same thing. Now everything works fine, and you think you had a bad starter. You may have never had a bad starter in the first place. So it's just one of those things you do to verify before. I'm not big on throwing parts and stuff. I mean, we sell enough parts. We can't build what we need to build now, so I don't want you buying stuff you don't have to buy. I mean, let's try to fix something first. Ring gear. Lycoming engines out here, you all got a ring gear, right? And that ring gear has teeth on it. And people will call me up and they will say, I need to know what starter to buy for my Lycoming. And I'll say what model, they'll say a 320. Yeah, you could have either 122 tooth ring gear or 149 tooth ring gear. And then we get into the discussion. How do I tell the difference between a 10-12 and a 12-14 pitch gear that's on that starter ring gear? There's a very simple solution. Count the damn teeth. If you get to 125, you've got 149, and you're good to go. You buy a starter for 149 tooth ring gear. It's the simplest way in the world. Just count them. Just count them. And all that other 10, 12, and 12, 14 and all that, it's all on our website. Waste of time. Just count the number of teeth. It'll tell you how many you've actually got. Let's see here. Broken engine kickbacks. Engine kickbacks are violent. That's a good word to say. They are violent. An engine kickback can destroy the starter in 33 milliseconds. It's not something you're sitting in the pilot seat and you crank it and the starter's going blah, 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 and then all of a sudden it goes backwards. Yeah, that's a kickback. But you might not even see this. It might just be a hesitation. And what will end up happening is you will literally break the starter and literally can break it right off the engine itself. It can be this violent. This violent. There we go. There's one that's broken. That's an engine kickback right there. And what happens is it just breaks the case, splits the starter, and literally can drop it right off the engine. I had a gentleman call me up and he said, something wrong with your starter. There's always something wrong with our starter. I don't know if you knew that or not, but it's always the starter's fault. He said, there's something wrong with your starter. He says, when I hit the button, all it goes zoom, zoom. Okay? So we went all through the basic troubleshooting, things like that. And I finally told him, I said, just take the cowling off and we'll check it, on the engine. And so he took the cowling off and he called me up and he said, I think I found the problem. And I said, what did you find? Because I'm always interested. And he said, the starter is laying in the bottom of the cowling. Yes, I think we found the problem. You're right. What he was hearing was, since the starter was no longer connected to the engine, it was turning, but there was nothing connected to it. So it just really kicked back, broke the whole thing off, and that was the end of that. So it can be, a kickback is an extreme event. You get a carbureted 540, no big deal. 0200, no big deal. But you start getting into the 200 horsepower, like the 200 horsepower Lycoming, the IO 360s or something, they can be a little touchy with that, especially if you're doing a hot start, hot day today, fuel injected, trying to get it going, things like that. It's a good time to get a kickback. Some of our starters have kickback protection, some do not, some's automatic, some you got to fix it yourself, just a variety of different ways. Troubleshooting cap checks. You all do your cap checks on your batteries? If you're certified, it's required every year. You got to do a cap check, make sure it'll maintain 80%. Right? That's the whole idea of the capacity. How many of you have gone out and jumped in an airplane and gone and flown it? Oh, nobody's going to admit to that? Wow, we used to do it all the time. In fact, I had an Oldsmobile 98 that had a 24-volt system, had 2 batteries. I could jump off a 24-volt airplane. It was a wonderful car for working around the airport. One of the most dangerous things you can do. You got somebody out there, you yourself are flying or a mechanic doing it, and you go jump the airplane, the guy, he says, oh, it's just been sitting here, I haven't flown it, blah, 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 type of thing, and you jump it off for him, he goes and flies, out he goes, gets caught in weather, up in the clouds he goes, and the alternator quits. What's the capacity on his battery? 0, because it was dead when he started. If you want to have a good explanation for it, think of it this way. When your airplane was it certified with a dead battery? If not, then it's not a legal flight. So it makes it an illegal flight. So be careful with stuff like that. Voltage drop, 0.5. These are kind of things, just numbers you can use. 0.5 volts, if I'm measuring, say my battery's in the back of the airplane, I measure the battery and it's 13 volts. I come up to the master switch, to the solenoid, and I measure that solenoid and it's got 13 volts. And on the other side of the solenoid where it goes to the bus, all of a sudden I've only got 12 volts. That means I've dropped 1 volt through the solenoid itself. That's not good. That's a lot. It's a steel bar, it's a brass bar, clamps down, and basically the current runs across. You shouldn't have any kind of voltage drop at that point. So if you've got something like that, you got to fix that problem. So we use numbers just to kind of give us something to actually shoot for. Let's talk about like grounding. So you got the engine out there, and you got a bonding or a ground strap that goes from the engine to the airframe, maybe connects to the engine mount that's bolted to the airframe, maybe goes directly to the airframe, whatever, but somewhere you've got some kind of a ground, all right? That ground shouldn't be any more resistance than 0.2 ohms. So if I just take an ohm meter, take an ohm meter, stick the engine on one part, put it on resistance, and stick the firewall. It should be 0, because if you've got a good ground path back to that firewall, back to the airplane, you're not going to have any resistance at all. But we use a number so we've got something for uncalibrated gauges, and things like that. So think about your grounds. Grounds are the #1 problem we run into, and I would say probably 80% of the problems that we hear about on the phone end up being some type of a ground issue, because so many of the airplanes are old. And they just, that ground strap's been there for 40 years. Sometimes you just got to take stuff apart, wiggle around a little bit, tighten it back down, and you're good to go. So watch your grounding. Torquing, of course, torque off fasteners, tune in, blah, blah. Duty cycle. Starter duty cycle is directly attributed to yaw. Because you're going to get that. Did you hear that, yaw? It's Alabama. Anyway. Directly attributed to you guys out there, because what happens is when you start, you go yang, 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 yang. How long should it be before the engine starts? I mean, how long does it really take? A couple seconds? Yang, yang, boom, and it's starting right up. Cars, obviously, now, you just hit the button, it's already running before you can even take your finger off that, but that's all electronically controlled. But for y'all, when you go ahead and you hit the starter button or you turn the key, it's yang, 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 boom, 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 blah, 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 and off it goes and it's starting. So if you have to sit there and go yang 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 yang, what are you doing to the starter? You are flat roasting it. You are roasting it, and any type of heat damage to a starter is all cumulative. So it doesn't go away when it cools off. It's just damaged that starter, and it's just going to continue to get worse and worse, and you will not get the service life you think you should get out of that. So watch your duty cycles. Okay, let's talk about alternators a little bit. Historical again, because I'm old. I've always has history stuff. These were a couple of AC generators. AC. So an alternator provides, or an alternator produces AC current, AC voltage. So it's AC voltage, right? Of course it does. It rotates. Anything that rotates creates AC. So you have a sine wave, right? You got your AC sine wave. What do we do to create DC? We have to convert that. So we convert that from AC to DC, and we do that with a rectifier assembly. And that rectifier assembly has usually a 3-phase alternator and has 3 sets of diodes, 1 positive, 1 negative, and what that does is allow the positive side to go through, and the negative side it cuts that off. So you end up with, this is Mr. Ferris, and He always is unhappy when I forget him. Do you believe that Chrysler had the first alternator? Chrysler had the first alternator way back when, 1960. Remember the old generator days? How many of you out here still have a generator? Yeah. I have no problem with generators. I think they're fine. But what happens when your RPM's down, you pull the power back, and the lights all get dimmer, right? Because you're taking the 12 volts from that generator, now maybe it's only putting 8 or 9 volts out, and the lights get dimmer. You used to be able to see that come up to a stoplight, the car, coming in their direction, all their lights would go dim. You knew he had a generator. This is the way it was in the old days when I was growing up. So they decided, we had to we got to have something better. So this Gene Ferrison for Chrysler actually patented the rectifier assembly, which allowed us to have DC output from an AC producing machine. Okay? That's how we got alternators. Alternator theory, basically you have a north and a south, 3 phases. We'll just talk about a 3-phase alternator. So basically, you're going to have some type of a sine wave. And that sine wave is going to be a positive and a negative, and a positive and a negative. And since you had 3 phases, 360 degrees divided by 3 is you'll have one every 120 degrees. Now, obviously, something like that would absolutely never work. So what do? We turn it faster. We can suck that sine wave in so those humps are closer and closer and closer together, right? Or the other thing we can do is we can do half-wave rectification and just dump that whole bottom half. Well, look at the thumping you got now. Now you have straight line DC, but it's thump, 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 thump. Can you imagine what today's avionics would see if they saw that? I mean, Garmin, they would just explode. They wouldn't know what to do. Their head would just blow up. So we can't have that. So we've got to do this differently. So let's go to full wave rectification. And now what we do is we take that bottom portion and flip it up on top. And by doing that, notice how our output DC is getting smoother. It's not great yet, but it's getting smoother. Now how about if we turn the alternator at 8,000 RPM? All this now moves back, so everything happens in the first section. And you get a nice straight line DC. And if you're still picking up a little bit of noise, because you got that ripple current on top, maybe add a filter or something to it. That'll get rid of that for you. So it's a simple way to do it, simple way to look at it. Generators, I got no problem with generators. Being old, I look at generators as if they meet your mission, and your mission is you go eat pancakes on Sunday and things like that, and the airplane does what you need it to do, then you are good to go. You're good to go. You don't need to switch to alternators. The big thing is, we got to have an alternator. No, you don't. Generator will do just fine as long as it will support what you're trying to accomplish. However, if you get to the point that you can't get parts for it, or you got to go down the auto parts store to get it fixed, things like that, maybe you need to think about switching over and taking a kit, taking a generator off, putting an alternator on. That might be time to do that. If you're going to put new avionics on, you're definitely going to do it, because it's hard for some of the newer avionics to live with what they call a noisy generator system. So you may go to an alternator at that point in time. Now, what's wrong with generators? Nothing. It's just that if somebody had a generator, how many amps do you have in your generator? 20 amps. So you got 20 amps of power in that generator. That'll support not a lot, but it'll still support the basic loads you have. Remember, only continuous loads. It'll support those loads. And how big is that generator? Give or take. Yeah. So let's just say it's this big around, and let's just say that long. It's the length. The length is the problem with a generator. You have to have a big armature on the inside, right? So you got this armature in there, and now I want to turn that armature at 8,000 RPM. The generator would explode. It cannot handle high RPM. Since it can't handle high RPM, we have to gear it down so that when you're at idle, you don't have it turning fast enough to get your output voltage that you need to keep the lights on properly. That's the only thing wrong. That's the whole problem. If I take an alternator that's this big around, just like the generator, but it's only that long, I can spin it at 8,000 RPM and it doesn't even know the difference. So I don't have to gear it down as much. So where a generator might be turning at 600 RPM, let's say it's a 1-to-1. It's turning the same speed as what the idle is. So if you're idling at 750, it's turning at 750. On an alternator, I can do it 3 times more because I can use a pulley that's 3 times. So I can sit there and say at 750, I am now turning the alternator at 15 and 750, 2250. So the alternator is well within its current and voltage producing range to support loads on the short end. And that's the only difference. If the generator works, leave it alone. You don't have to worry about it if it takes care of what you're trying to accomplish. Hundreds of different alternators. There's Ford, Chrysler, Prestolite. We have some. They have some. Probably the interesting thing here is the Ford alternators. We don't own the Ford alternators. Cessna does. Cessna owns the rights, as they call the intellectual property, the IP for the Ford alternators. So somebody calls me up and they say, I need the maintenance manual and all that stuff for a Ford alternator. Call Cessna. So they call Cessna technical support, and guess what Cessna tells them? Call Hartzell. We don't own it. I can't do that, right? I can't do that. You have to provide that for them. Piper is the same way with Chrysler. Piper does not remember that they own Chrysler. But if you go back to the old Piper manuals, if anybody would have one, they actually had overhaul instructions in the aircraft manual for that alternator. And guess what we use today to overhaul them? That same data. Because it's still good data. It's the most current thing out there. So it's okay to use. Prestolites, of course, they've been around forever. Hartzell, we have our own. Then there's Jasco and Plain Power. There's all kinds of different types of alternators. That's a Ford, Chrysler, Prestolite style. This is what goes on Alt 2 on the Cirrus. Jasco, anybody out here running Jasco? Gosh, I wish somebody would run them. Plain Power, of course, very, very popular for the conversions. This would be on Alt 1 on like a Cirrus, something like that. This would be like a replacement for 421, Continental per mold engine, gear drive alternator in the front. Okay. First thing I need to know, when you tell me the alternator is in op, what is in op? Is it voltage? Won't do voltage? Or will not carry a load? That load is that continuous load. Will it not carry that load? Or is it just flat, you're running on battery, you got no output voltage? That's what we need to know to be able to effectively troubleshoot it. So you got to remember the voltage is controlled by the input from the voltage regulator and the speed of the alternator. The amperage is controlled by the bus. The amperage is, the bus itself says, hey, this gentleman has turned on, this lady or gentleman, has turned on these switches. Those switches add up to a continuous load of 27 amps. The alternator will now supply 27 amps, and the voltage regulator will maintain that at 14.2 volts. And then somebody turns on, that same person turns on 2 more switches. And those 2 more switches add up to 20 amps of continuous load. Now I have 47 amps of load. The alternator says, no problem, well within my limit. I supply 47 amps of continuous load. The voltage regulator picks that up and still supplies the same 14.2 volts. So there's 2 different sources. So if you tell me that you have an amperage problem, won't carry a load, that's the alternator on one side. If you tell me you don't have any voltage, that's the alternator parts of another side. So we need to know that to be able to tell what to do next. And this is basically, I'm not going to use these numbers because they really are more confusing than anything else. There's our voltage drop and full field, and there's a troubleshooting technique they call full fielding the alternator, where you basically cut the regulator out. You put straight battery to the field of the alternator, and then the only thing that controls the alternator output is your throttle. Because the faster you turn it, voltage goes up, because there's no voltage regulator to control it. So you can check and see if you actually have output. Won't tell you if it'll carry a good load, but it will tell you if you have voltage, if you have voltage output for the alternator. Let's see here. Yep. Aux terminals. We got way too many people that call us up and they say the alternator's not working. There's a field 1 and a field 2. Field 1 is from the regulator coming into the field. Field 2 is a ground. But unfortunately, I have a lot of people that connect that field 2 to the aux terminal. The aux terminal is a power output. So now I've got 12 volts coming this way, 6 volts coming this way. The alternator is effectively seeing a 6-volt input, so it puts out half. That's really simplifying it, but basically that's what it ends up doing. It's all because it's not wired correctly. And it's a simple thing to determine. The aux terminals are only there for an alternator out situation, like maybe you have a light, something like that, some type of a sense, or if you have a multi-engine airplane or multi-alternator setup, it tells you if one alternator is working and one is not. There'll be one that's out or something like that. That's all that's for. Otherwise, you'll never use the aux. That's enough. Alternator noise, is it mechanical or is it electrical, right? 0.2 ohms of resistance then. Grounds are the #1 reason you have noise in a system. It's the #1 reason. But the one that the third paragraph down there, installed toys. This is one that's really become big again. Back in the 70s, I think, they used to have cigarette lighters in the airplanes. You all that might older used to smoke might remember that. They used to have cigarette lighters in everything, in fact. And a cigarette lighter, remember those kind? You pushed them in, you pulled out, it was red, just literally red hot inside. All that is a direct short, right? You run it through a coil, you have some resistance there, you push that thing in, you short it, you're basically shorting your power coming in, and you pull out as glowing red. So the one circuit in the airplane that had no circuit protection was the cigarette lighter, which doesn't make a lot of sense when you're creating that much heat in an electrical circuit. So they came out with this brilliant idea, and they said you got two choices, either buy this kit and redo it and all that kind of stuff, or just remove it from the airplane. The majority of people just removed it from the airplane. It was better because you didn't have all the smoke inside, and all that kind of stuff. So that was what most of them did. But now they're making a comeback. Now they're called an auxiliary power port. Yeah. And why do we need an auxiliary power port? Because we have so much electrical crap to plug into the airplane that we need all this stuff to plug it into. So we put these things on, then we put splitters on so we can plug more in. Okay, I don't care. Doesn't matter to me if it's a proper auxiliary plug that's properly installed. Except the components that you're plugging in, had they ever gone through any testing that would approve them for use in an airplane? So how do you know that when you plug that laptop in, or you plug that iPhone in, or you plug something, whatever, a game, you plug these games in, how do you know that that's not what's causing your entire electrical problem, why the strobes aren't working right, and why you're getting noise in the headset, and who knows what else? Because you're plugging this thing in that's never been tested to be used. Okay, so installed toys are a big problem right now. All right, the other thing is diodes. You want to check a bad diode? Just check your alternator output. If you check the output with a VOM, you put the VOM on AC. Once it's on AC, then just check and see how much you have. You should never have more than 1 volt of AC. If you do, you've got bad diode. And there's nothing you can do about that. The alternator's shot. So it's just the way it is on that. Let's see here. No alternator. Oh, here we go. Alternator's electromagnet. Think about it. We just talked about this. You've got a rotor in the alternator. You've got current coming into that rotor through the field. That's all part of the field circuit. In the end, it goes to ground. I have a wire. So when I put current through that wire, I create an electromagnet. When I create that electromagnet, then I should be able to take, remember when you were a kid, you took a nail, you wrapped a bunch of wire around it, you put a battery to it, and you could pick up other nails because you create an electromagnet. So if I want to find out if the alternator is going to output, how about if I just turn the master on, that brings battery on the bus. How about if I turn the alternator on with a field switch, that brings power to the alternator rotor system, and then I just take a hacksaw blade and see if I got magnetism. Just lay it on the pulley, lay it on the top of the alternator. If I have magnetism and the alternator's turning, when you turn the alternator, it doesn't output, it's the alternator. You've got a bad alternator. If I don't have magnetism, it's up the other direction, which means you probably have a bad regulator or the wiring in between. Very simple way to troubleshoot it, just to give you a general idea right off the bat of where the problem may lie. Okay. Gear-driven alternators. How many of you, anybody here run per mold engines, Continental? Okay. With the gear drive alternator? Here's the gear drive? Is it? Okay. On the gear drive alternators on the per mold engines, there's a gear clutch assembly on that. It has a lot of attention from the FAA right now because there have been a lot of problems of these not being installed correctly. and where they're not installed correctly, and something happens, they break inside the engine, they trash it inside the engine, you've got 30 grand you're looking at for an IRAD. Did you really? Yeah, that's unfortunate because did they determine what was wrong, what happened? Yeah. Yeah. Have I already talked to you? Because that's exactly what happens. This thing, when you put the gear on, you got to torque and you got to make sure it's on there right. In fact, I'm doing a seminar just on that. You put that on there, you got a cotter pin. The cotter pin's never bent over the top. It's supposed to be just bent flush. You never go above the top of the rotor. If you go beyond that, when it's inside the engine and it's turning, it engages into the face gear, what's called the face gear inside the engine. It is such a tight tolerance, it will literally, there's two tabs that hold the bolts on the face gear. There's 4 bolts. It will literally turn and it'll grind off that tab. The bolts will loosen up, face gear comes loose, and the whole thing disintegrates. And then you have lots of money. Got lots of money. Nobody else has had that problem? The FAA wrote an SAIB. I don't remember the number, I can tell you, I could find it. But there's an SAIB on proper installation of these gear couplings. If they're installed incorrectly, it's just not a good thing. Wow. Come see me Thursday morning at Superior Air Parts. I'm doing a forum just on those alternators. Might be worth looking at. So it's one of these things that, it's not a good situation because it causes a lot of damage. And of course, these gear couplings have a rubber insert in them. And if you get all that rubber down inside the engine, now you plug up your oil passages. Now you have an oiling problem with the engine. The engine just disintegrates itself and you're basically stuck with nothing, except a lot of money. And hopefully you get down okay. That's really the main thing. M0 Standards Manual from Continental explains exactly how to put this thing on. It replaces 2 of the earlier service bulletins, but even if you use those service bulletins, you're not going to do it wrong. There's just additional information in that M0 manual. So it's a bad situation on those. These are just some troubleshooting numbers. They're okay if you're knowing what you're looking at, but the ohms themselves, whether you're doing a field, it doesn't have to be these numbers. It basically has to do with how much resistance is in that circuit. That's all you're trying to figure out. Think about it. You got brushes, right? Got brushes that go against the slip ring. If the brush wears out, the spring tension decreases. If it decreases, you got less pushing on the slip ring. Less pushing on the slip ring means might bounce a little bit, and the system sees it as a flutter or kicks the system out because it sees a fault. This is a troubleshooting guide. We have all the troubleshooting stuff online. No big deal that way. I wrote this several years ago. Notice it starts from the top right and goes left. And I always told everybody this is because the mechanics, they want to start at step 1 and go to step 7, so I make them read it right to left. Very hard to read that way, right? Actually, I can tell you guys the truth, but the reason I did it on a spreadsheet. I had no idea how to flip it when I got done. So it kind of just stayed that way. PMAs and STCs, we have all kinds. We have OE parts, we have PMA parts, we have STC parts, we have TSO parts, and you need to know what the difference between those are to make sure that what you're putting it on, that's a legal installation of what you're doing. I'll give you an example. STCs. If you're going to install an STC, that STC has to be compatible with any other STCs that are already on there. That's your responsibility, or as they say, the installing person or agency. You have to make that determination. You can't just keep adding on STCs and hoping everything works out. You got to make sure that it's compatible with that. Okay? And that's the responsibility of the installer. PMA parts are simple. They're typically just bolt-on. They should be direct replacements. Parts manufacturer approval replaces something directly that's already on there. STCs are a little wider, broad, that you can actually have to do a little, I'm not going to say modification, but you got to do a little work sometimes to get everything to line up right or do what you're doing. OE products are something that we manufacture let's just say, I'll pick on Robinson helicopter. So we make an alternator for them. It's RH24-70. It's nothing more than a plain power AL24-70. But because it's got their designation and part number on it, none of our data is acceptable. You have to get their data. And so people call up Robinson, they say, I need the data to tell me what the TBO is on the alternator and how to repair it. And what does Robinson say? Call Hartzell. Can't provide it. We don't own it. Same thing as the Ford situation before. We do not own the IP for their product, even though we build it for them exclusively. So if it doesn't fit, you got to go to the FAA and get all that fixed. 4313, and if you're building an airplane, if you don't know what 4313 is, you need to stop, go find it, and read it. It's got a ton of information. It was a Bible when I was going to AMP school like 100 years ago, and it is still great information and good information. Works certified, works experimental, gives you all your fuses, your circuit breakers, your wiring, your blah, blah, just all kinds of different stuff. And heavyweight and lightweight, we kind of talked about that already. And let's see here, a couple examples. We used to have a Seneca. Years ago I had a Seneca, and we didn't have lightweight starters then. But when you loaded the Seneca with 2 of us and a flight bag and full fuel, we were just over the CG limit forward. All right, so we'd always take the flight bag, take out what we needed, what we hoped we needed, and throw the flight bag in the back in the baggage compartment, and that would bring everything just back within. It would have been a perfect time to have lightweight starters, because the forward CG then would have backed up, and we could have kept all the flight bag right up in front with us, instead of having to climb over the seat to find it when we had to go someplace else that we didn't think we were going. You know, so that's a great reason to go lightweight. Experimental, you know, experimental guys, y'all are shifting CG all over the place depending on whatever your engine is and what you're trying to build. Batteries in the back, batteries in the front, using a light combing engine with a big old heavyweight starter up front. You can put the lightweight on, back up the CG again. I mean, you can use the light and heavyweight. I've actually had some people actually go to heavyweight because they didn't have enough forward. They need to add more to it. And then the Cessna 21 guy, excuse me, that's what I told you about earlier. Just maybe skip a few pieces of pie. All right. So basically, I've been out. Got a few more, but you know, I'm kind of done. But you want to see some pictures? I'll show you some pictures of some of the junk we find. Okay? This is grounding. Look at this one. Is that a good ground? You can't tell me that's sitting there. You don't have a clue. It may be perfect. But when I look at it, I see a cable, a heavy cable with the old cloth braid on it that's coming apart. So that tells me that cable has no longer been protected, which tells me that moisture and anything else has penetrated it, which means you may have a high resistance connection right there at that terminal. Those other ones, and why do we have so many on one spot? How many grounds do you actually need? Yeah, you need one ground. You don't need everybody that put a piece of equipment on this airplane over the last 20 years. Well, I got to wire it, I got to put a ground on. They put another one on, and another one on, and another one on. And what happens is you have a split where you split the grounds, and it looks at it electrically and says, oh, then what we'll do is we'll use our Ohm's law formula, and we're going to split this parallel path up, and we're going to split all that resistance at the same time. And guess what? You got no ground, because it can't calculate it that way. So you need one good ground. I would take each one of these, find out where they go to, and I would almost be willing to bet you at least one of those lighter wires probably goes to something on the airplane that doesn't even exist anymore, because it's been changed over the years. The heavy one's probably your engine case to airframe ground. The only one that matters is that big one, and it doesn't look like it's in too good a shape. Here's the gear coupling we were talking about. See the interface, and you can see along that gear, you can kind of see where that face gear has been tracking. And that's what you want. You want... Do what? Oh yeah, yours is probably all over the place. Yours is probably all, yeah. And that's what it should look like. It should be tracking center line between the face gear and that per mold and the gear, the alternator gear itself. That's what you want. My guys, when I was telling them, what they would do is they would put that on. We had 2 people verify the torque when we put the thing together. 2 people verified the cotter pin, and we would put the alternator on with a little bit of Prussian blue on that gear, put it on, put a couple bolts on and nuts on just to hold it in place, turn the prop through, take it back off, and we would look and see where that was tracking. Because you know what? You got 3 manufacturers coming together there. You got Continental with the face gear and the case itself. You got us with the alternator, and you got whoever, various ones that manufacture that gear coupling and or overhaul them. So now we all have our plus and minuses. What if you get a plus, plus, plus? You're going to ram that gear right in that face gear, and when you do that, you'll either start peeling off all that orange material you see there, or if you, not just that, you're pushing it so hard in that face gear that it puts a load on that shaft. So every time it turns, instead of going and spinning, it's going whoop, 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 whoop. You take a metal rod and you bend it back and forth enough, and guess what happens? Just snaps. And when it snaps, you know where that gear goes? Bloop, in the engine. Now it's bouncing around. Then it could just damage everything there, or it could just exit right out the side of the engine. Here's pieces. That's what's left of it, okay? Notice the gear coupling itself, no big deal. But look at the shaft that's on the top with the circle around it. Look at the woodruff key. That's the woodruff where the key slot. Notice how wallowed out it is. That doesn't happen after the fact. That coupling was loose when it was on. Now you've got a loose coupling, so instead of it turning, woo, it's turning, wobbling around, you know, and it can't find its place on that face gear, and the whole thing disintegrates before you're done. But I can tell that in 1 second, if I get that, I look at that slot there, and I know, okay? This is the SAIB I was talking about. The FAA feels this is very important, enough that they wrote an SAIB, which is 1 level below a AD. We do service bulletins as a manufacturer. We do various levels of service bulletins. The FAA uses SAIBs and AD notes. So this is just them trying to say, hey guys, we need to look at this closely and figure out what's going on, why we can't get these gear couplings installed.
I submitted an MDR to FAA. Should I hear from them?
Good. Will you hear from them?
Will I hear from them?
I don't know. You might. I don't know. I don't know what their procedure is on stuff like that anymore. I don't know. Yeah. Yeah, this is not an what you're telling me is not an unknown thing. I mean, they wrote an SAIB for it. Yeah, yeah, well, that's the good part, yeah. You still had to pay something. You're still paying. Okay, corroded terminals, are those corroded? They look like, I mean, they've been on there for a while. Look at how you can see the white. Look at the rust on the engine, the field terminal there, and you got that white stuff all over, that corrosion. Just take that, break it loose, wiggle everything around, tighten it back up. You'll fix anything that's causing a problem with. We do on some of the alternators, you have to pull the brush block assembly out. You do it every 500 hours. This one, there's a bottom nut there. That bottom nut got loosened, so the carriage bolt dropped down, and when it got pulled back up, it didn't get pulled into its little slot. And when that happened, it's just sitting there, and notice how the shunt lead is just going to bounce around on there. So that's going to give you an intermittent alternator. Probably more intermittent than working, actually. There's a brush that got put back in, wrong. So instead of running on the face, it somehow got back in there on the side, and when it did that, it shorted against the shunt wire coming through. But it actually worked for a while. It's like, wow. There's one. This one came back in. This was a alternator that came back in, and we found this nut jammed up in the stator. That nut is, I call those turbine nuts, and it's just my old way of saying it. To me, those are a turbine nut, nothing of which we use. So somehow, that nut got into that side of the alternator and wore through the varnish that's on the outside of that stator, and you can see the result. It just shorted right there where you see the smoke color right at the nut itself. So that shorted the stator, and of course the output was gone just like that. Circuit breaker popped, you know, the whole bit. Here's even a better one. The nut that's on the bottom is the positive terminal. Okay? The nut that's on the burned up side on the 2 o'clock part, something like that, is the ground terminal. This person had taken the power cable, connected it to the output terminal, and tie wrapped it to the ground terminal. It just vibrated, went right through, and it had a direct short from the output of the alternator right to ground. There was smoke everywhere. Scared the crap out of him. And then he got mad. Your alternator, my alternator didn't do that. So here's a bunch of different pulleys. This is what we were talking about kind of earlier when we were talking about with generators and alternators and things like that. There's all kinds of different pulleys. And some of these pulleys are OE pulleys. The picture where it shows the special, see the helicopter pulley that's kind of on the top there? That pulley is $225. Yet I will have people send an alternator in as a core, and it'll have that pulley on it. Wait till they go buy one. Okay, so make sure that if you have a special pulley on there, it comes off before you send in that unit. Because technically, I cannot send that back to you. Because once it comes in, it's not our product because it's like a Lycoming pulley or something, so I can't certify it to send it back out. Now, if you call me up and you tell me, hey, I left the pulley on there, I will go out and I will try to find it. If I find it, I will put it in a little brown bag and I will send it to your name, and I'll act like I have never talked to you before in my life. So, dry belt style, single V-belts, double V-belts, serpentine or the multi-groove V-belts. Why do you have to change V-belts? What's the purpose of the V-belt? Drives the alternator, right? So what if I have an alternator 60 amps? No big deal, single V-belt. What if I have an alternator that's 150 amps? They may feel they need to go to a multi-groove to have enough torque when it's operating at full power. Not required necessarily, but they may look at it that way. That double belt thing was the worst thing they ever did to an alternator. Because there was never, I don't know if any of you remember, but back in the old days, you could go into an auto parts store and you bought a package of alternator belts, they were matched together. Then nobody does that anymore. And what that did was when you went and did your your tensioning, one belt was tight, one belt was looser. And it just played havoc with the bearing in front. For one thing, you're sticking it out that much further, the pulley, which means the load on the bearing it's a tremendous amount more if you go out that far. It's a whole lot different. This is just different things we have online, videos and things like that. You're welcome to go look at them. You just go in there. They're 3-4 minutes. Wealth of information. They're really good stuff. I thank you very much.